Hello everyone, welcome back to our channel. Now we are going to discuss about few problems on motion under gravity. In our daily life we can feel that acceleration due to gravity is there. How we are feeling? Suppose any person is jumping, he is reached to the ground. When we are throwing one ball, it is going to some height, then it is coming down. Suppose we are taking one ball, okay, when you are throwing upwards, it reached to the maximum height. If we know the single parameter maximum height, see the given problem is a ball thrown up from the ground reaches a maximum height of how many meters? 20 meters. The given height is that ball is reached to the maximum height of 20 meters. From this, based on these 5 questions are there. First one is find u, means initial velocity. Then second one is time of descent. Velocity, with how much velocity it is hitting the ground. Then fourth one, displacement between 0.5 meters to 2.5 meters. Then next one is the time at which above 15 meters from the ground. How to solve this one? When we are doing these problems, we feel that suppose one ball is there, that ball is projecting upwards and we don't know the velocity, we can consider that velocity is u. And if you want to draw this, you can draw this one. This ball is projected upwards from here to here. The height is 20 meters. With how much velocity we are projecting u? First question is find u. What is the maximum height of this one? H equals to u square by 2g. Here h equals to, we know that clearly 20, u square by g value 2 into 10. After simplification, u square equals to 400. Then u equals to 20 meters per second. Once we know the velocity, our next question is find the time of ascent, means t equals to u by g. Here u equals to 20, g equals to 10. So t equals to how much? 2 seconds. Then third question is with how much velocity it will hit the ground. We can use the third equation of motion. V square minus 0 square equals to 2 into g into h, because starting velocity is 0 in the case of freely falling body. So v square, v equals to under root 2 into 10 into h is already, we know that 20 meters. Under root 400 is the 20 meters per second. From this, what we are understanding? Projected velocity is 20 meters per second. And when it is reached to the ground also 20 meters per second. So always we should remember that with how much velocity we are projecting, with same velocity it will reach to the ground. Suppose we are applying the 2 meters per second. Then it reached to the ground, same 2 meters per second. So no need of doing here. How much projected velocity means 20. Same thing we can write it. Okay, I want to prove this one. That's why I have given solution. But while doing that problems, we should remember that projected velocity and reached velocity both are same when the body is projected vertically upwards. Then our next question is the displacement between 0.5 meters to 2.5 meters. So, when displacement between 0.5 seconds to 2.5 seconds, so we can take it y1 equals to velocity is 20, this time is 0.5 minus half into 10 into t square. 0.5 whole square means 0.25. This is 25. Then y2 equals to same 20. Instead of 0.5, we can take it 2.5 minus half g is 5 into the 2.5 whole square is 6.25. When we are doing the displacement is y2 minus y1. We are doing this one minus this one. Here 20 is the common. 2.5 minus 5 is the 2. Then minus, in these two 5 is the common. Minus 5 is the common. Here 6.25 minus 0.25 is the 6. Do the simplification, we are getting y equals to 40 minus 30. So that displacement equals to 10 meters. If we know the time and we know the initial velocity, we can find out the displacement at 0.5 seconds and displacement at 2.5 seconds. Then we can find the gap between them. Then our last question is the time at which above the 15 meters. In this case, we don't know the time, we should find out. But we know that how much height is there. Total height, maximum height is how much? For that maximum height is u square by 2g. Already we have solved this one, and they have given in this problem that is 20 meters. So at 15 meters, if the ball is reached to the 15 meters, how much time it will take? So E we are doing same problem formula, we are taking y equals to ut minus half gt square. But instead of y, we are writing 15. U value is 20. T minus half g is the 5 into t square. 5 1 ja, 5 4 ja, 5 3 ja. So we should write it t square minus 40. We are sending this down this side. Plus 3 is equals to 0. After simplification, you are getting t equals to quadratic equation 4 plus or minus under root b square 16 minus 4ac means 12 by 2a. Then t equals to 4 plus or minus, this is also under root 4 is the 2. When we are taking the plus, you are getting 6 by 2 equals to 3 seconds. When we are taking minus, 2 by 2 equals to 1 second. 1 second. So these are the answers for these 5 problems. Next problem is, if the body is projected from the top of the tower, that too vertically projected. They have given initial velocity is 10 meters per second and time is how many seconds? 5 seconds. With the help of these two, we have to find out height of the tower. You know that here initial position is above the final position, means displacement s equals to minus h, and it is projected vertically upwards, means instead of a we are taking minus g. So we can go through the second equation of motion, that is s equals to ut plus half at square. Instead of s minus h, ut minus half into g into t square. Minus h equals to velocity is how much? 10 meters per second. Time is the 5 seconds minus 1 by 2 into 10 into 25. Then minus h equals to 50 minus 125. So answer is 75 meters. Like that we can find out. Generally height of the tower means some people are there forgetting we are taking minus h. Some people are forgetting that instead of a they are taking plus g. So don't do that type of mistake. Whenever the body is projecting vertically upwards, that too from the top of the tower, means we can take it h is the minus, nothing but displacement is minus, because the initial problem is the body is projected from the top of the tower. You are here and you are projecting one stone vertically upwards with how much velocity? v1. And your friend is on ground and simultaneously he is projecting another stone with how much velocity? v2. So here two stones are there. You are projecting the stone vertically upwards from the top of the tower, and that height is h we are taking. And your friend is projecting one more stone, I say at the same time, then it is moving with how much velocity? Projecting v2. When both the stones will meet, how to find out this one? Look here, suppose this stone is going up, later it comes down and both will meet here. We can consider this distance is x, means total is h, means this part is h minus x. Anyway, first case, you are projecting the stone from the top of the tower, means we can take this expression h equals to half gt square minus ut. So, but the distance is how much here? h minus x equals to half gt square. For removing that minus, we can take this minus v1 into t. In both the cases, timings are same. Second one, we are taking x equals to v2t minus half into g into t square. From equation 1 and 2, from equations 1 and 2, when we are adding 1 plus 2, what we are getting here, h minus x plus x is the, we are getting once again h, and here we should add half gt square minus v1t plus v2t minus half gt square. These two are cancelled, h equals to t into v2 minus v1. So when both will meet, directly we can use h by v2 minus v1. Based on this, we can do one problem also. If h equals to 80 meters, v2 equals to 20 meters per second, and v1 is 10 meters per second. In this case, how to find when both will meet? 80 by v2 minus v1. Directly we can use, and we can save the time also. This is 10. Answer is 8 seconds. At 8 seconds, both the stones will meet. Then our next question is, we are taking 3 stones here. We are taking 3 stones. One stone is projected vertically upwards from the top of the tower. Look here. First stone is projecting vertically upwards. It will come. Next stone is, it will take t1 seconds to reach the ground. Then second case is throwing downwards. It takes t2 seconds. Then last case is like freely falling body. We can consider t. With the help of, we know 3 things here. One is projecting vertically upwards from the top of the tower. Here how to write this expression? Here all the towers are having the same height. H equals to half g t1 square minus u into t1. In second case, throwing downwards, h equals to, but the time is t2, t2 square u t2 plus half g t2 square. Here both are covering the same height, means we can equal the two. So half g t1 square minus u t1 equals to u t2 plus half g t2 square. With the help of this, we can find out the velocity. When we are sending this term is this side, this is this side, u into t1 plus t2, and this side half g is the common. It becomes to minus, we are getting t1 square minus t2 square. So u equals to half into g into, it should be right, a square minus b square formula, t1 square minus t2 square. So t1 minus t2, t1 plus t2 by t1 plus t2. So this one cancel. We know the velocity, u equals to half into g into t1 minus t2. Then in third case, we are taking, that is the body is dropped. So h, but here h equals to half gt square formula. Instead of h, we can take any expression here. In this case, h equals to u into t2. So half gt square equals to, instead of h we are taking u equals to half g t1 minus t2 into t2 plus half into g into t2 square. In all cases, half g is common. You can take the cancel also. T square equals to, here t1 into t2 minus t2 square plus t2 square. After simplification, t equals to under root t1 t2. So during the problems, if they are giving one body is projecting vertically upwards, it takes t1 seconds. If the body is throwing downwards from that height, that time is t2. Then third case, if the body is freely falling, means direct formula we can take it. And we do one problem also based on this. Look, if t1 equals to 4 seconds, then t2 equals to 9 seconds, then t equals to how much? Under root 9 into 4, 36. It is the 6 seconds. Like that we can calculate the problems. Thank you. Please subscribe my channel.